Looking at section 3.4, problem 2. This problem is very similar to the example. In fact, I'm not going to go through the process of finding the derivative again, because the only difference here is that this has a 5 in the numerator instead of a 3. All the steps that we did in that example are going to be the same, and so what we're going to get for our derivative when we find it at the end of that process. And again, if you want to go back and check example 2 for that one, procedure is almost exactly the same here, but we'll find the equation of the tangent line, just not the derivative. So the derivative was negative 3 over x squared. Here it's going to be negative 5 over x squared. So we'll use that for the second thing that we have to do. But for part A, what we want to do again is find the slope of the secant line through x equals 2 and x equals 5. This one I think I'll have room to actually draw that. So remember that the slope of the secant line is f of b minus f of a over b minus a. So in this case, they want us to do this at between 5 and 2. So we want f of 5 minus f of 2 over 5 minus 2. So the first part, we're not actually even using the derivative. We're just going back to what the slope of a line is, slope of a secant line. So f of 5, what do we get when we plug 5 in there? We're going to get 1. And what do we get when we plug 2 in there? We're going to get 5 halves. And then 5 minus 2, 3. So if we find our common denominator here, we can write that as 2 over 2 minus 5 over 2. That's going to be minus 3 over 2. And then this is over 3. Remember, you can write that as 3 over 1. So this is minus 3 halves times 1/3. These 3's are going to cancel, and so we're going to get minus 1/2. So that's the slope of the secant line. And then for part B, we want to find the equation of the tangent line when x is equal to 2. So for that, we're going to need to know what is f prime of 2. So to do that, I just plug 2 into the derivative, so minus 5 over 2 squared. So that's going to be minus 5 over 4. So remember that to find the equation of the tangent line now, we have to find the y-intercept of that tangent line. We know that the slope of that tangent line is minus 5/4, because that's what the derivative tells us. And then the only thing we need to do is find b. But remember how we do that. We know that this tangent line has to pass through the same point as the function itself. So in other words, f of 2 is equal to 5 halves. We found that already. That means this tangent line is going to pass through the point 2 5 halves. So what we can do is then plug 5 halves in for y, and plug 2 in for x, and then figure out what b is. All right, so here we can, to simplify this, the 2 and the 4 can cancel. That becomes a 2. So we're going to have 5 halves is equal to negative 5 halves plus b. So I need to solve for b, so I'm going to add 5 halves to both sides. That's going to get me 10 halves. 10 halves is actually 5, so b is equal to 5. So the equation of our tangent line is y is equal to negative 5/4 x plus 5. Okay, and I said I was going to try to graph this, so maybe I can fit that in here just so we can see kind of what's happening. So the function that we started with was 5 over x. I'm not going to be too exact about this, but 5 over x is a function that kind of does this kind of thing. And we're really only concerned with what happens for positive x values. It does this over here, but we're not going to concern ourselves with that part of the graph. So the first thing we did was we found the slope of the secant line through these two x values. So that was 2 and 5. So suppose this is x equals 2 right here, and maybe this is x equals 5 out here. So what we did first was we found the slope of the line that passes through those 2 points. Okay, so that line right there. That is the secant line, and that line had slope -1/2. The second thing we did was we found the equation of the tangent line. And the tangent line, remember, is the point that just barely touches the graph, only at that one point. And that's a line, so there again it has an equation that we are familiar with, y equals mx plus b. And that's what it is. Minus 5/4 x plus 5 means that the slope of this line is -5/4. The y-intercept is 5, so that point right there, that y value would be 5. Okay, so the first one was the slope of the secant line, that line that cuts through those 2 points. The second one was the equation of the tangent line.